Thank you very much. I'm holding.
Okay, go ahead.
Hey, everybody. Yes. Okay. All right, finally, I'm ready. All right, well, welcome, everybody. I'm John Romero, co-founder of id Software, and I'm going to take you on a journey back to the beginning of id Software. Are you ready to be entertained? Yeah? All right. I do realize that some of what I'm about to say may sound insane, but we were in our 20s when we started id Software, and we didn't know that there were any limits. So I grew up in this wonderful small town in Northern California named Rockland, which population was only 6,000 people. So in the 70s, I was massively addicted to spending loads of time in dark arcades and playing all the games there and getting really good at them. Was anyone else in arcades over here? No? Yeah, there were some people. Well, in 1979, it looked like this. Before anyone had a computer at home, including me, I went to local college when I was 11 years old. And I started learning BASIC from the college students. I just went up to them and I started asking them what the words were on the screen. They showed me their listings, and I just started writing down the words and started experimenting with them on this HP 9000 mainframe that was in the next room. So to keep me at home, my parents got an Apple II Plus. So I was done going outside. I spent all my time programming games on that computer. So a few years and 20 Apple II games later, I finally learned 6502 assembly language. It was a language that all fast arcade games were written in. Then I could really make some 80s games like these, except not quite. Not quite arcade games, but home computer games, which were on the Apple II. So we'll just say that the Apple II was my personal home arcade, as well as 1 million other Apple owners. So when I was a sophomore in high school, which was, I believe, second year of secondary school here, I did some programming for the Air Force when I was 15 years old. We lived in England then, and my stepfather worked for the Air Force. So in order to get into the high school programming class, I had to show the teacher that I could program in 6502 assembly language, and I ended up at the aggressors squadron the next day. So I was literally coding in a bank vault. And because I was a kid, they gave me false data to use with my code. So I can't tell you what I was programming because that's classified. It's odd, but a true story. So after high school, I kept making games, and by 1987, I was working at Origin Systems. My first job was porting 2400 AD, an RPG, from the Apple II to the Commodore 64. So by this time, I had made 74 games in 3 previous game startup companies, which were these Capital Ideas Software, Inside Out Software, where I ported Might and Magic 2 to the Commodore 64, which some of you may have played, I think, yeah? And a company called Ideas from the Deep, and I was 21 years old. So I went to work at a company named Softdisk at the start of 1989, and I learned how to program a DOS PC there for the first time, and was making a small game or a utility every single month for about a year. Then I created a game product called Gamer's Edge at Softdisk, and I had to hire a team of game developers, so I was finally going to have a team. So I hired John Carmack and Adrian Carmack, not related, into my department for programming and art. And then Tom Hall came in at night to help us out, since he was already at Softdisk and he loved making games. So this was the first time that any of us had actually worked with another person on a game. We had been making them all alone for 10 years each, and it was pretty incredible. So while creating our first game together, Slordax, which was the screen a couple screens ago, John Carmack discovered what we call the smooth scrolling trick on the PC. So Tom, Hall, and John stayed up until 5 a.m. making a demo called Dangerous Dave in copyright infringement, because it was basically a ripoff of Mario. So the next day, I saw the disk on my desk, and I ran the demo, and I watched the screen scroll smoothly, pixel by pixel, and it was a massive eureka moment for me. It was like a bolt of lightning. So I'll elaborate why in a moment, but id Software was born that instant on September 20th of 1990. So one thing led to another, and we spent a week putting together a demo of Super Mario 3 for Nintendo. We had this cool scrolling tech, why wouldn't we use it for Mario, obviously? So we sent it to Nintendo. They really liked it, but they decided not to publish our game, or to take on this port, because they decided to only publish their intellectual property on their own platforms. And so this was the Nintendo, which was a pretty smart move. So no problem, we just used the technology for a different game, which was called the Commander Keen Trilogy. Yeah, Commander Keen. Anybody remember Commander Keen? A few people. So why would a side-scroller be a huge hit in 1990? Well, because no games on the PC could scroll horizontally smoothly per pixel on the PC, which had been out and available since August of 1981. But in 9 years, no one had figured out how to make the screen scroll smoothly per pixel until the Dangerous Dave and copyright infringement demo, which led to Commander Keen. So does anyone remember the original Duke Nukem game pictured here? All right, Duke Nukem. So it scrolled by in chunks of 8 pixels, like other games of that era, which was why Commander Keen was such a revelation. So the reason why Duke Nukem scrolled with any speed is because I taught Todd Replogle how to do it while he was programming a game called Dark Ages, the game he made just before Duke Nukem. So the Commander Keen Trilogy provided the start of id Software, and we made these 3 games in 3 months. It's probably about 2.5, from September 20th to December 14th. So it was a massive hit for us, and it was super popular. People cosplayed as Commander Keen for years at events. So the game pioneered the creation of game engines. We designed the game as an engine that operated on different data for different games. So it was the only way to get the trilogy done so quickly. In fact, in 1991, when we were working on Keen 4, we started licensing the engine for the first time, so it was the beginning of the modern engine licensing business. So development on our games went very, very smoothly and quickly because we stuck to some core principles that are important even today. So through the talk, I'm going to highlight some of our core principles at id Software. I'd like to highlight something else right now, namely this photo. Has anybody seen this photo before? Yeah? No? Probably not. Well, it's a picture of us at our lake house in Shreveport, Louisiana, when we were starting to make games together. So the funny thing is that people have asked me for years, what is in this picture? So I analyzed it recently and decided that I'm going to show you what's in here. This is what you see. So this is John and me in early September 1990. We were working on the Super Mario 3 game. The Super Mario 3 demo that we planned on sending to Nintendo. We both worked on the huge D&D table that John had. We used to play D&D on the weekends, and those sessions led to the ideas for future games like Doom and Quake. This is us again. There's a whiteboard here. Computers were brought home on the weekends from the company. Don't do that. You need to have your own computers at home. Back then, it was hard to get a 386. So this pic was taken on a Saturday or a Sunday because we worked at home on the weekends on the game. On top of the monitor is one of those old Intel reflective astronaut plushies. To my left is my notepad, which is a task list of bugs to fix. And that's our high-level task list of what had to get done to finish the demo. And this is Tom Hall's area where he was doing all the graphics for the demo. He recorded gameplay on a VCR, and he played it back, pausing the action so he could duplicate the tiles of Super Mario 3 exactly in Deluxe Paint 2, which was the Photoshop of the 80s. So the TV set had a 13-channel selector on it, and it was connected by an RF modulator, so it was very old school. So id Software was founded formally on February 1st of 1991, and we made 12 games that year. Shadow Knights, Dangerous Dave in the Haunted Mansion, Rescue Rover, Hover Tank, blah, 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 blah. So we actually took 2 months to make each game, but we made 2 games simultaneously. And this was due to us having 10 years of intense game development experience prior, but it was also due to our first principle. Back then, we had no prototypes. Just make the game, polish as you go. You don't depend on polish happening later. Always maintain constantly shippable code. This is how we made so many games so quickly. We had the entire game in our heads. We knew what it was. We just needed to quantify what needed to be done, and then went about working on it until the game was finished. So there were no prototypes for our early games. We just made them. So remember, we were a small team of 4 people, and we could do this back then. Large teams definitely require more planning. So here's a quick story. One day, it rained really hard, and Cross Lake in Louisiana rose up, and it was flooding everywhere. And I needed to get to work. Like, we were working furiously on our games, and I had to get back and keep on coding. So I just got ready, go down the street in the car and everything, and saw this. The entire road was flooded. So basically, I got out and I waded through this flood water, dodging water snakes all the way to the house where we had id Software, and then took another shower, and then got back to work. We were all so excited to be making our own games 24/7. Also note that during this year of 12 games that we were making, we also moved id Software from Louisiana to Wisconsin. So that takes a lot of time out of game development, but we couldn't afford to have anything go wrong while we were making our games at such a pace that we created another principle that kept us developing quickly. So it's incredibly important that your game can always be run by your team. Bulletproof your engine by providing defaults on load failure. So if you have 100 people trying to develop a game that will not run, you're paying for 100 people to sit around and wait for it to get fixed. So we recognize the importance of keeping the game always playable and decided to bulletproof the engine by making all the inputs solid. Game engines typically fail because they're trying to load bad, corrupted, or non-existent data. So checking for this and providing a standard default for failure case will keep the game running quickly and show you what's missing. So if you fail to load a sprite, you're trying to load a sprite and it fails, just show a bagel. So the theme song's not working, play something horribly wrong for the game. And if you're missing the sound effect, do the same thing. Something really annoying. So after 1991, id Software's first stage of company development was complete, and another important principle was in effect at this point. Keep your code absolutely simple. Keep looking at your functions, figure out how you can simplify them further. We wrote all of our games up to and including Quake in straight C, no C++. So stage 2 is about ready to begin for us. In August of 1991, we decided to move to Madison, Wisconsin. So Tom Hall and I visited at that time, and we found it to be really nice, as Tom used to live there while he was in college. So we moved all 4 of us up there, and we continued working on our games. Only 4 months later, we were found dead in the snow, victims of Wisconsin's brutal winters that we did not research. So the moral of the story is do your research. We knew how to program an assembly language, but not to ask Tom Hall, hey, what are winters like up here? So after 6 months, we moved to Texas. So we had a new principle. Great tools help make great games. So spend as much time on tools as possible. I wrote a tile editor in 1991 named TED for Tile Editor. TED was used for 33 shipped retail games. several of which were even 3D games like Hover Tank, Catacombs 3D, Wolfenstein 3D, Spear of Destiny, Rise of the Triad, Corridor 7, and others. So it was January 1992, and we decided to go all 3D based on Catacomb 3D's promise, which is this game here. It looked cool, it just didn't play very cool. So Wolfenstein 3D took 4 months of development to get to its shareware launch with 1 episode of levels. And it took 2 more months to finish all 6 episodes and to write a hint book for this game. In the first month, it sold 4,000 copies, all priced at $60 each. And Spear of Destiny took 2 months. It was a prequel to Wolfenstein 3D, and it was retail only. And soon after that, Tom Hall traveled to Kentucky to work for a couple months on Wolfenstein VR. Yes, this was 1992 VR. So it was awful. Back in the days of Commander Keen, I had discovered a small 3-person game company named Raven Software while I was up in Madison, Wisconsin. And I called them up and went over, and we introduced ourselves. And flash forward 7 months later, and we did a little work with them by modifying the Wolfenstein 3D engine and then licensing it to them for a game called Shadowcaster. Shadowcaster's tech improvements were sloping floors, lighting, and fog. And this engine looked slightly better than Wolfenstein 3D, but it wasn't good enough for our next game. So John Carmack spent some months thinking about how much more advanced this new engine should be for the game that we decided to call Doom. Yeah, Doom. Based on the rapid development of our previous games, we came up with another important principle. We are our own best testing team, and we should never allow anyone else to experience bugs or see the game crash. I know it seems impossible, but don't waste other people's time. Test thoroughly before checking in your code. No throwing it over the fence for testers to find it and put in a bug report, and then you get to fix it later. It's a wasteful cycle. Let's do it right then. So after 1992, id Software's second stage of company development was complete along with another principle. As soon as you see a bug, you fix it. You do not continue on. If you don't fix your bugs, your new code will be built on a buggy code base and then ensure an unstable foundation. If you check in buggy code, someone will be writing code based on your bad code, and you can just imagine the cascading effect there. So the ideas for Doom came from our D&D campaign, which was full of demons. We also loved the movies Evil Dead and Aliens. So Doom's design was a mashup of ideas. At the beginning of Doom's development, we created a new core principle, which was use a development system that is superior to your target to develop your game. So before Doom, we were making games for DOS while we were developing on DOS. And we knew that we could do better if we used more powerful computers and a more advanced operating system to develop our games. So we developed Doom on Next Step workstations. They were far superior to DOS. Next Step eventually turned into OS X/OS X. And this also meant that one of our core principles was upheld, which was that great tools help make great games. So we could make far better tools on Next Step. DoomEd and QuakeEd were 2 of the most important tools that we had. And this was a screen from 1993, which you would not find in DOS. So these tools, they really helped us create levels and to test them very quickly. So you might not have known this, but we had 5 people on our team creating Doom. After Tom Hall left, during Doom, we hired Sandy Peterson and David Taylor, which brought us up to 6 people. So unbelievably, while making Doom, we had to stop all game production and create the Super Nintendo port of Wolfenstein 3D as fast as possible. So because we were starting from scratch, never having programmed a Super Nintendo, it took us 3 weeks because we had to learn the hardware. Then we jumped back to making Doom again. Couldn't waste any time. So we uploaded the shareware version of Doom to the University of Wisconsin server on December 10th, 1993. So the excitement for the game was unprecedented. People were creating files in the upload directory that were sentences like when.will.we.c.doom. We got random phone calls in the office asking when it would be out. So, quick story. During the final days of Doom's creation, we worked 30 hours. 30 hours in a day. So we had the game running on all computers in the office to ensure that it was solid. However, on a couple of computers, the game froze up. So the menu could be brought up, but the gameplay stopped. John Carmack thought about what could possibly be happening, and he figured out the solution without doing any debugging. So he's correct in his solution. We finally uploaded the game after the 5-minute fix and more testing. So at the beginning of 1994, I started working with Raven Software and developed Heretic using the Doom engine. Anybody here play Heretic? Yeah, Heretic. I wanted to see how an inventory system in a medieval version of Doom would play out. So it turned out great, and we thought the result was excellent. We wanted to keep on working with them. So we also made Doom 2 in 1994. It took us 8 months, and it was released on October 10th. So in addition to this, we did the Jaguar Doom port ourselves. So again, we were multitasking and making multiple games. So 2 games in 1993, and then 3 games in 1994. In 1995, we started working on Quake. We had 9 developers, meaning 4 designers, 3 coders, and 2 artists. So I was the only one to do both coding and design. I wrote QuakeEd and experimented with level design in full 3D. Again, we started with a clean code base. We had no code from Doom used in Quake, which was basically another of our principles of development was write your code for this game only, not for some future game. You're going to be writing new code later because you'll be smarter. Also, you're not tying yourself down to the limitations of your past code. So invent new things. So Quake's engine was being developed by John Carmack, and the rasterization was by Michael Abrash. People here know Michael Abrash? Michael Abrash is an awesome programmer. You should all know who he is. Look at Dr. Dobbs' journal if you want to see. So John Cash worked on the network code, and John Cash went on to become the lead programmer of World of Warcraft. So another quick story. This relates back to our belief that developing in a superior operating system can result in a better game. So while making Quake, we made a deal with Cray supercomputers to buy a Cray 6400 super server for half price. So our plan was to have our development team connected to it to BSP and LiDAR maps, as well as crunch whatever new kinds of data that we would create with our next game's engine. The computer room in Quake's DM3 level was going to be full of Cray computers as a reference to this new hardware that we're going to acquire. Unfortunately, Cray was bought out by Silicon Graphics before Quake was finished, and the whole deal fell apart. So the computer room in Quake was filled with the usual rectangular mainframes instead of the C-shaped Cray computers. So after publishing Heretic, I started working with Raven on Hexen. I wanted to see how an FPS would play with a hub level system and character classes, and Hexen launched on October 30th of 1995 during a deathmatch event called Deathmatch 95 that was happening at Microsoft's campus in Redmond. Anyone here play Hexen? Yes, good. It's a good game. So a month later, I got Raven started on my next game design, which was called Hecatome. It would be the 3rd game in the series. Heretic, Hexen, and Hecatome. But Hecatome was never finished. It was turned into Hexen 2 because I had left id Software at that point. And it also was not the same game design. During this time, we noticed a small game company making some nice games like Raptor, Call of the Shadows, and we brought them down from Illinois to Texas to make a game that we would publish. They called themselves Rogue Entertainment, and about 14 months later, they released a game called Strife, which used the Doom engine. Anybody play Strife? No. It was an FPS RPG, and it was really, really fun, and it's on Steam right now. It showed that by combining genres, we could actually make a really fun FPS. Nowadays, we have games that are, FPS RPGs like Destiny and other ones, but Strife came first. Also, during 1995, we made the Ultimate Doom, which was a retail version of the full version of Doom with an extra episode that we created specially for it, and the Master Levels of Doom, which was 21 levels plus thousands off the internet. So id Software was still 9 developers in size. We released 2 games in 1995 while we're working on Quake. Work continued on Quake, and 14 months after starting, we released Q-Test on February 24th of 1996 for the world to test our internet gameplay. During the next 4 months, we worked very hard to complete Quake. We also released Final Doom, which was created by Team TNT and the Casali brothers, and Death Kings of the Dark Citadel, which is an additional set of levels for Hexen. So one important principle that helped us get Quake done faster was this one. Encapsulate functionality to ensure design consistency. Examples of this in Quake would be simply the torches that were on the walls. We could have made, us level designers, place a torch model and then a fire model and then a torch sound entity, all at the same location. But then, if we needed to move a lot of stuff around, something could have gotten left behind. It was far easier to just create a torch entity that had all the functionality already built into it. So also, the water in the game needed sound effects as well. And we needed to place sound entities all over the place to fully cover all the water areas so you would hear it everywhere. But if the water got modified, then moving all those entities around and deleting them and all that stuff, that would have been a big mess. So it was easier to just make the game play water sounds when the water was actually being rendered on the screen. So it was a renderer level feature, and it was out of the designer's hands, which ensured consistency and it saved memory. So we did the same thing for the Sky Audio in Quake as well. I released Quake shareware on June 22nd at 5:30 p.m. on the University of Wisconsin at Madison's website. Time for another quick story. So while Michael Abrash was programming the renderer, he was interviewing CPU instructions with FPU instructions to calculate perspective correct texture mapping. So sometimes while he was playing the game, for just one frame, the game would show a completely different place in the map. So he isolated the only instruction where it could possibly happen and determined that it was impossible for it to be an invalid value, basically to return a 0. So he had a friend from Intel come to the office to go through his code and go over his analysis, and his friend agreed with him and told him that there was a known error with the floating point divide instruction on the Pentium. It was a hardware error because the computer was overclocked. So there was nothing that we could do about it, so we left it alone. So this bug is actually known as the Pentium FDiv bug. You can find that on Wiki. So Quake is a game that introduced the world to mouse look, high-speed true 3D, and internet multiplayer. Clans sprung up immediately, as did esports and tournaments everywhere. So Quake World launched 5 months later. So making games was and still is our life. Like, we love it more than anything else, as you can tell by our release of 28 games in 5.5 years by less than 10 people. Many other games were released that used our licensed technology over the years. So here are some more core principles that we learned from doing all of this work. Try to code transparently. Tell your lead and peers exactly how you're going to solve your current task and get feedback and advice. Do not treat programming like each coder is a black box. The project could go off the rails and cause delays. Programming is a creative art form that's based in logic. Every programmer is different and will code differently basically don't waste time focusing on a rigid coding style. It's the output that matters. So we keep working to make great code, and it's in our blood, as I'm sure it's in your blood as well. It's why you're here at We Are Developers. You want to be the best, so go be your best. And thank you very much for inviting me to speak here at We Are Developers, and I'll do QA right after this. Thank you.
Okay.
Now we need a microphone
Well, first of all, we have a question here that someone's put through the app. This is from a person whose name I'm not going to attempt to pronounce. What is your favorite game?
That's difficult. I really like World of Warcraft a lot. Chrono Trigger was previously my #1 game for a long time. And it just made #1 RPG of the top 100 RPGs just a few days ago on an IGN list. I really like Ghost Recon a lot, the original Ghost Recon. But Minecraft and WoW are probably the two games I could just jump in and just stay in. So I'd have to say that those two are kind of even.
Nice. Okay. Now, you can still send in questions, but because we need some more, does anyone want to shout something out, and I'll repeat it so everyone can hear? Any hands? Come on, guys, you will not get this opportunity again. Yes, right here.
What is your favorite programming language?
What is my favorite programming language? Right now, I think it's Lua. I really like it. We're doing a bunch of work right now in Unity and C#, and we've been using Lua for years. And if you're not a game developer, you'd probably be surprised to know how many games are made in Lua. Has anyone here heard of Grim Fandango? Awesome game. That game is all Lua. In fact, Lua controls the game engine. It's the main loop versus the game engine being the main loop. But a lot of games use Lua. In fact, just hundreds and hundreds of games have been published with Lua. World of Warcraft uses Lua for all its UI. So I'd say Lua just because it's kind of the perfect language to teach people how to program in, and it's powerful enough that you can make games that are performant.
All right. Now, I've suddenly got tons of questions here, right? So well done. Thank you. Here's an interesting one. Do you think your principles that you outlined here can be deployed nowadays in the game industry?
Oh, definitely, yeah. I mean, that's kind of... I gave this talk to King.com for the first time, and to 700 programmers, so I think there's more here. and I think with the exception of the no prototypes, which is just an id software only kind of thing, I think pretty much everything else is extremely important. And there's other things that we learn from developing that are, I think, still really true and really help developers basically progress faster. Probably one of the biggest pieces of advice that I have is to, when you're programming, only program for maybe a few minutes and then test your code immediately. Don't write code for half an hour even. Because now you're getting into a lot of deeper bugs versus something that's pretty quick. So if you write just a few lines and you run your code and it breaks, you know exactly where the problem is versus a half hour writing a whole system or a bunch of interleaved functions. Now you're diving into a bunch of code and trying to figure out something that may have several levels of error in it versus you just typed a few lines and were able to test your code. And you know exactly where the problem is. So you avoid deep debugging if you just test your code quickly. So highly iterative development, I think, is pretty much the best thing you could do.
All right. I've got a really interesting one here from Marco, and I also had this question earlier on, which is, what did you use for version control back in the day?
Version control did not exist back in the day for us. So, starting in the 80s on the Apple II, you had a floppy disk, and if something happened to it, your code was gone. Like, there wasn't even really hard drives back then to kind of save it. And backing up meant you had to have two drives so you could copy from one disk to put on another disk. So even with id Software, our version control was the fact that everybody had a copy of all the code on everyone's hard drive. So if something happened, you could just copy it over. And at the beginning, before the end of 1991, we basically used to copy our files onto disks and just pass disks around. So I used to draw all over the disk, so everybody had a special disk just for them. And so it's like, this is Romero's Fortress or whatever, and everybody would have their own little drawings and stuff. And some of those we still have those disks around, but those were our copy. We tried anything that we could. We tried serial cable stuff, and it basically came back to just sneakernet, walking floppies back and forth until we got an actual hard drive file server, a Novell NetWare 311 file server in November of 1991. And I had mentioned that John Cash was the network programmer for Quake. We hired him from Novell directly to id to do that. And anyway, so we were big fans of Novell back in the day. So then my first version control wasn't until probably 1998, I'd say, with SourceSafe.
Okay.
And so nowadays I prefer SVN for more indie kind of projects, and then Perforce for game projects. And because we make games in the same location, I don't use Git because Git is really good for big distributed groups. Mm-hmm. So I wouldn't use Git.
All right. I'm sure there's going to be some nightmares tonight from the floppy disk story. All right. Blaz asks, opinions on OOP versus functional programming in game dev. Do you have opinions on this?
I think functional is something that people like to do because it's cool. I think it's
Flame war starts.
it's fun to take procedural code and turn it into functional code. I think that's a cool thing to do, but it's not performant. And when you're making games, you have to do it quickly. I'm not saying we use go-tos, but we don't use functional programming just because it's a little too restrictive. We need global state. We don't want a ton of returns from functions that are nested. So yeah, we functional is cool. There's nothing wrong with functional programming. But we just do it just because sometimes it's fun to do it it's not actually in the game. It's just like, oh, I turned it into a functional. I turned all this into functional code. It's pretty cool.
Okay.
It's cool in the logic sense.
Right. All right. And let's see what we have here. Okay, from Andri. Andri asks, would you publish a game in Steam first if you develop a game nowadays, or would you rather publish it yourself?
Well, publishing yourself doesn't mean you can't put it on Steam. Mm-hmm. So we just made an indie game called Gunman Taco Truck, and it's about you're the last Mexican in the United States, and you start in San Diego, and you are trying to get to Winnipeg, Canada, where they have no taco trucks and they need tacos really bad. And so this is post-nuclear apocalypse. So the United States is basically turned into all mutants. Most of the animals, some of the humans have become mutants. And your job is basically to go down the highway to the next sanctuary city, blow away all the mutants that are trying to destroy your taco truck, because you have a big gun mounted on top. You blow everything away, and when you blow stuff away, you pick up the meat, because you're serving that meat in the next town as tacos. So you're serving up the roadkill to everybody, and then you're moving on to the next town. And so all the roadkill changes, all the tacos change, and you're just trying to get enough money to get the gas to get to Winnipeg. It's a really funny game.
I got to check that out. Okay. Florian asks, VR in game development, how do you see the future? I think, how do you see the future of VR in game development?
I think VR might be cool for level design. I think it might be fun to do design in that. I haven't felt any limitations doing level design with 2D monitors. So we'll see. I mean, I haven't tried the Unreal 4 stuff yet, but I know that they have VR Oculus headsets working with the level design tools in there. Most of the time, though, when you're doing stuff in a modern editor, you're placing static meshes versus doing BSP stuff. If you're doing BSP, it's kind of temporary because the goal is to replace all the BSP with static mesh. So you're really just doing a lot of placement. So you can do it in VR or you could do it on a screen. It's still 3D no matter what. It just depends. Is it more fun? Probably more fun in VR.
All right. And here's one from Tom, who asks, how did you not get distracted and just spend all your time playing games?
No internet. In the 80s, there was no internet. Like, I didn't even have a modem until probably 88, I think. So there was just there's nothing pops up on your screen. Your computer could only run one thing. Most of the time, it was running a command prompt. And then you would run your program. So there's zero distraction. Phones back then were crappy. So, like, we didn't get phone calls. So we just kept making games. That's all we did. So we would go have food, come back. There's zero distraction. And nowadays, it's insane, right? Yeah. Nowadays, have fun not being distracted, trying to do anything. So you actually have to be super disciplined nowadays. I mean, we were really disciplined back then. Nowadays, I think you have to be even more disciplined to keep yourself super focused. You have to, like, basically quit out of everything and stop background tasks running.
Yeah. I'm not sure exactly if he meant distracted from other things or distracted from playing the game itself that you're making right now.
Well, you have to play the game that you're making. It's really important. Really big dev teams, a lot of times they don't play the game that they're working on, and that kind of ends up in being a game that's less than stellar. But it's really important to play your game and make sure that it's fun and it's doing well and it's fast. And, you know, it's at the point that you're making your game, if you could release it right then, it should feel fast, it should not be buggy, and it should be fun. And that should happen all the way from alpha until you actually do your release. Before that point, it's completely unfinished.
Right.
There's a person right there if you want to ask him.
Yeah, oh, yeah, hi.
Considering fast, you said that you were developing on better hardware than the mainstream, so how could you make sure that it actually runs quickly on mainstream hardware?
How do you make sure that your game is going to run fast on mainstream machines versus the development machines? So it's important that you have normal computers at your office that you can test your game on. So you're developing on crazy machines, and then you basically get a machine that is, you can buy crappy machines, it's pretty easy. You buy some, and you have it in your company, and you test it on that. So if you can, when you're working with a publisher, you kind of, as soon as possible, you determine with the publisher what is minimum spec for this game. And you get that computer, and that's the lowest that you can go. So you make sure that your targets are kind of being hit every time you make new builds. You can go run them on that. And if you have a really great build system, if you use Jenkins and you have it push notifications to Slack and all the kind of cool stuff, and you have really good unit tests, you could actually use bots to measure frame rate on the crappy machine to make sure that you don't have to have a QA person running through it and telling you it runs badly in some area. You could actually have unit tests and stuff to actually do that for you.
All right. Michael or Mikael asks, what advice would you give to people that want to start making games?
My advice is to go home and do that right now. There is no reason why you can't make games today. There's nothing stopping you. You don't need permission to make games, which I've had to tell people forever. You can go and download everything for free. All the information that you need is free. Everything is out there. Everybody's run into all the problems. They're all in Stack Overflow. You basically just start making games immediately, and my advice is start small, make very small games, something that you think is ridiculous, like Pong. Have fun making Pong if you're not a programmer, and you need to learn how to make a game. So if you're not a coder, don't shoot for the stars. You're not making an RPG. Try to make something like Pong and see how that experience goes for you. Then try to make Space Invaders, and then try to make Pac-Man. You won't still even see how hard it was to make those games when they were created in the late 70s and in 1980, but you'll get a sense of how hard it is just to make a game run well. And just to architect a game.
Good. So do it.
I would say use Corona SDK at coronalabs.com, which is a Lua-based SDK that does not put you into an IDE. It's basically use whatever editor you want, Sublime, whatever, and you just have your simulator over here, your code over here, both on the same screen. Type in some code, save it, it reloads. It's being super iterative, almost the way that Swift 3 has playgrounds, but this is cross-platform. This goes on Windows desktop, Mac OS X desktop, Android, and iOS. So you can have your game on all those platforms.
Can you say the name again?
It's called Corona SDK.
Corona SDK.
If you just do a search for that, it's a dream. It's amazing.
Cool. All right, we've got time for 2 more, and I've got 2 questions about bugs.
All right.
So first of all, Paula asks, what is your favorite bug that ended up as a feature in a game, if such a thing exists?
Geez, I don't know if it's a bug. So silent BFG in Doom, does anyone know about that? The silent BFG? So if you're playing Doom, when you make a sound as a player, you have one sound channel for the player. So every sound that you make is on one channel. And you can cut off your own sounds on that one channel, because there's all these other sounds going on, especially in multiplayer. You're going to hear other people and all the stuff going on in the environment. We had to make sure that the player sound was dedicated on a channel. So when you shoot a gun, that makes noise. When you hit the wall, you go on the wall, because you're looking for secrets, hopefully. That makes noise, but that will cut off other sounds. And so the BFG, when you start it up, it actually has a big, long buildup before it actually takes off. And so if you fire the BFG while you're in front of a wall and then you hit space, you cut off the sound of the BFG. And that's network cutoff as well. That's not just local on your machine. It cuts it off over the network, so the other players in deathmatch don't know you just fired the BFG. Then you basically just step out and they think you didn't do anything. And the way the BFG works is very special. You could launch the BFG into one room, strafe over and look in the other room, and when it hits the wall in the room you fired it into, you'll kill everyone in the other room. It's a really crazy way that it's programmed, but you take advantage of the silent BFG trick and then the way the BFG works, and you can just like destroy people pretty quickly. So that was a cool feature.
That sounds like a
Especially for
feature,
me.
definitely a feature. All right, and the last one we have, also on bugs. We like to hear other people's pain as well. What was the most time-consuming bug you have personally had to deal with? What was it?
There was a bug when I was implementing compression, really just zip compression and decompression on a Pocket PC platform device. And there were a lot of issues. Well, there were two problems, but there were a lot of issues with that. One, the API was pretty badly documented. And when I finally got it working, what I did was I had zipped up the hundreds of files into one big zip file. And when I was trying to pull files out of that, it had to decompress basically the whole thing to get at that file, which is a really bad way for me to organize my data. I found out that the best way to do it is to zip every little individual piece of data and then just pull it out and unzip it. So that was like an 8-hour nightmare because of the way that you have to work with Pocket PCs. Mm-hmm. That was Pocket PC back then. And then the other one was the first time I was trying to connect Lua to my C++ code. Lua has a C interface that you basically go from Lua to C to whatever. And I was using, to do it quickly, I was going to use a whole bunch of other people's glue, Lua glue, and none of that stuff worked. And it was I was on my 4th day of trying to get it to work, and I even had an expert person who had gotten me into Lua that was trying to help me get it working. And finally, on the last day, I was like, I can't spend any more time on this. If I don't get this connected, I'm not using the language, which would really suck because I think the game would go a lot faster in development if I had it connected. So I finally basically said, I'm not using anyone else's garbage. I'm going to look at the Lua manual, and I'm going to read what it says and do it myself. And it took 30 minutes. It was ridiculous. Stupid. Read the manual, do the work yourself.
NPM users take note.
Yep.
All right. Well, I think I'm sure you could go on for hours with this, but we've got more to do. So I would like to say a big thanks to John.
Thanks for having me.
Everyone give him a round of applause. That was absolutely fantastic.
All right. Thank you.